Love it. All right, Ken, I'll hand it over to you to do introductions first, and then I'll kind of just take it away after that. So, Karen, I don't know if you can just introduce yourself real quick and who you are, what are you doing for the team, and then
Oh,
we'll go from
okay.
there.
I didn't know if you wanted to start with me. Yeah, so my
Yeah.
name is Karen. I'm going to be the teaching assistant for this presentation of this course. So I have a lot of different background in computer science, data science, AI, all that sort of stuff. And I really look forward to doing what I can to help all of this, all of the students here, all of you guys here with your learning. And
From
I
the
live
team
in
here.
Moab. I live in Moab, Utah, and the background is like one of the canyons here.
Love it. Yeah, I was gonna say I'm based in Dallas, Texas, so I have
Oh,
a
cool.
concrete jungle all around and have to
Oh,
drive
I
out an
see.
hour before I get
Yeah,
to
I mostly
nature.
see red rock jungle around
Love
here,
that.
which is a really nice thing. This is actually this picture is as if I'm sitting is on this overlook over this confluence of two canyons here.
Love
Place
it.
I used to hike to regularly.
Awesome. So yeah, Karen's gonna be managing chat in the Zoom. Again, I think for the first session, just so I get a feeling of my own, just on how time works. We'll try and do. Feel free to drop any chat into the Zoom chat, and then the last 30 minutes, so from 3 to 3:30 Eastern time, is open office hours, and we can just chat and have fun there too. But yeah, on my end, my name is Alexander Booth. I am the head instructor for this course with IBM. Based on like who I am, my experiences, I've been in the data science and machine learning field for over 10 years now. I currently work for a cloud company called Databricks. They do AI, machine learning, data engineering for big data, help accelerate a lot of those use cases for large organizations. Been at Databricks for about a year and a half. And before that, I worked in the front office of the Texas Rangers Baseball Club. I led their data science and machine learning, basically the Moneyball side of the house. So using data science to help make decisions around which players to acquire, which players to cut, how to make baseball players better, how to set up the defensive shift. We'll kind of learn about it in this course, actually, which not today, but over the next 10 weeks. But I like to say that I helped ban the shift, the defensive shift in baseball. So back a few years ago, so a lot of baseball analogies over the next few weeks. But yeah, a few years ago, baseball players could stand wherever they wanted to when they played defense. And so we kind of use that, we kind of optimize that. If I know that George always hits baseballs to the left, then it makes more sense to put all my baseball players on defense on the left of the field. And so it turned out that I was really good at stopping hits, which fans didn't like. So the actual commissioner of the league stepped in and made a rule that you have to have two people on each side, even if most of the time George hits the ball to the left. I know. But it kind of goes to fun things about like how data science actually changes kind of the game that we play. And then on my end, I actually interacted a lot with players and coaches and tried to I have to communicate and tell those stories to them about why they should listen to us and why they should do things like that. So on the Databricks end, I'm still pretty involved with a lot of the sports clubs that utilize kind of data and AI. And then I also work with a lot of the digital native, Fortune 500 digital native organizations doing cutting edge AI work, such as like Workday and Rivian and a lot of these big kind of tech companies as well. So a lot of experience in the space in terms of teaching and presenting. I actually taught a data science boot camp, kind of similar to this for the last 5 years as well, since COVID, when a lot of kind of these teaching enablements went online. I also manage and run some of the enablement sessions through Databricks as well. So I may drop some of that into chat whenever I teach them as well. But yeah, welcome to the IBM Data Science course. It's a really good course. I've been working kind of with IBM and with kind of the lesson plan design team for a while on this. So a couple things just to take away straight from the course, and then we'll dive into the actual content of the lecture. This is an async course, mostly. Of course, you have me like an hour and a half, a couple hours a week. But this is an async course, which means you all are choosing to be here, choosing to participate, and choosing to interact kind of with the content. There is a ton of content. It's a lot of videos, a lot of scrolling, a lot of text. There's a lot of stuff here. So definitely, as we'll kind of go week to week, I'm going to call out some of the 10,000 foot views, the big ideas where you should really be focusing on each week. But know that it's whatever you put into it, you'll get out. Time in is going to equal benefit out. So sure, you could go through the next 10 weeks, logging in a couple times a week, spend an hour, a couple hours kind of on all the sessions and things. And sure, you'll pass or get your certificate, but you're not really going to get the most out of it, right, of the course. So definitely, I highly recommend kind of logging in almost every day, sitting down, dedicating a couple hours to actually focusing on the content. You'll see as you kind of go into the different sections of the course, it'll tell you a recommendation of how long different aspects of it will take. So for example, these first three kind of sections here should take around a couple of hours. Honestly, they're high. These are very high estimates. It won't take you 2 hours. But it gives you a sense of like, okay, I should be putting time into this. One example, I don't know how many of y'all went through the optional modules. Module like two and like module one, these are like in module A and B, these are insane. They have so much content in them. Like I was going through some of this earlier and I was learning a lot and kind of it was taking like almost just a few hours to go through all of these. So these are optional, but I highly recommend doing them if you do have any free time. You finish a module early, or like the week one module, the data science kind of foundations. It's pretty high level, pretty basic. So if you yourself like having extra time, please go back and run through some of these optional modules as well. So the way that the week will work on Wednesdays, the kind of next module will open up. You'll kind of work your way through it in your own async pace. Each module will have 1 to 2 discussion forums. I log in every single day, sometimes multiple times a day. So you'll see me being in the discussion forums. Feel free to say whatever you want in there. I'm going to try and add like more specific modules or I guess forums as well. For example, if you have anything you want me to bring up during our live sessions, I'm going to spin up one of these for every single week. And then, yeah, maybe some general questions if you have questions about content or actually executing any of the labs, etc. The actual media sets that you're going to have each week to run through, it's going to be a combination of videos, text, and then labs, which hopefully you have a little bit of a sense with already. We're going to run through 3 of the labs today in our live session, but just as an example, if we go into media set 1.4 here, you'll notice that, oh man, God, that's the hopefully, there we go. So if we kind of click through some of this media set here, you'll see that we'll have videos to watch, text to read, infographics to look at. Then we'll have a lab to run. So this is a lab that we should be able to open up. And then we should be able to run everything in here. I'll come back to this in a second. And then the last thing is quizzes. So there's like a little kind of quizzes at the end of each of these sections for you to just kind of test your understanding on. Note that none of these labs or quizzes within the modules are going to be graded. The only thing that you really need to care about for a grade is going to be 1.10, the assessment quizzes. You'll need to do those each week. I'm pretty sure they also lock the next module if you haven't done kind of the quizzes at the end. So make sure to hit the assessment quiz at the end. Let's cool. And then for my end, obviously I'll be in the forums, so feel free to ask me questions. No question is too silly, whether it's technical or not. Like I'm here to answer all your questions. So feel free to drop anything in there. On Mondays, we're gonna do a kind of live session like this where I'm gonna be running through the labs pretty quickly, but I'll be running through the labs just to kind of so you can see kind of what we're supposed to be doing for them. And then also on Wednesdays, I'll be recapping. I think I'm going to be making videos, so we'll see how good my TikTok or YouTube video editing skills are. I'm going to try and upload like a short video of like, again, just reiterating the high level 10,000 foot views from the previous week. All right, there's a lot of rambling. So summarize. You get what you put into the course. You can pass the course, get your certificate, and put like with 1 hour a week. You're not going to learn that much though. There's a ton of content in this course. Not you don't have to memorize every single detail, every single instance of every single lesson. That's not the point. But you are going to be exposed to a lot. I like to say that coming into this, again, we all come from different backgrounds and kind of careers. You don't know what you don't know. So the point of this class and giving so much information at once is to at least expose you to what you don't know. right? And then even after the next 10 weeks, you can go back, you can go do some like other research and kind of dive deeper into some of maybe these topics that we mentioned. Maybe I mentioned neural networks and computer vision at a high level, but you want to know more specifics about it. You can dive into that as well. Cool. Any kind of questions about the campus, online campus, or the content? I think most of y'all have worked your way through at least to the first class discussion. So hopefully you've seen some of these videos and kind of modules and text and stuff. Cool. All right. Let's see. What else do I want to share? Great data sets from Kaggle. Just while I'm on Kaggle, if you need more exposure to do more work, again, like we always want to be learning more, right? Hopefully you all have a Kaggle account now. I definitely recommend kind of registering at least. We're going to be pulling data sets from Kaggle over the next 10 weeks as well. So definitely make sure to make an account here if you haven't. And then one thing that I wanted to highlight is Kaggle Learn. I'm going to drop this in the Zoom chat. But Kaggle Learn are free micro courses that relate pretty extensively to what we're doing in this class. So for example, in module 2, you're going to learn how to start learning how to code, start learning how to code things kind of with Python. Obviously, there'll be some hands-on stuff that we'll be doing in module 2 with some of the videos and the labs. But there's a micro course, or there's a couple micro courses on introduction to programming. So if you've never had any programming experience before, then highly recommend kind of doing some of this to be hands-on. It's all free. You actually will write code, kind of run code kind of through kind of Kaggle's engine. And again, you can have like Python for, we're going to be covering all of this next week as well. So definitely highly recommend logging. Let me log in. You can prove that I'm not just talking out of my butt here, and I actually work through most of these on my own. I got some certificates somewhere of some of these, but yeah, highly recommend kind of working your way through Kaggle kind of learns here. You get a certificate when you finish each one. If you send them to myself and Karen, maybe I can use it to give some extra credit. You never know. I haven't figured out I haven't figured out too much on the grade book yet. But yeah, we'll see. There's no harm in doing more kind of work and more learning and things. It is, like I said, only 10 weeks, so the whole course is going to fly by and you are going to be taking a lot in. So that's my last little piece of advice I'll leave you with. We all have imposter syndrome. I have imposter syndrome here now, just kind of work with my work at Databricks and kind of even with you all. Uh, I get it. It's so much. Don't feel like you have to memorize everything. If at the end of the lesson you kind of have a high level understanding and that 10,000 foot view of like at least uh, what is data science, what is interacting with data, what does it mean to make analytical decisions, data-driven decisions, and finding kind of those insights at enterprise scale, then like that's kind of enough, right? So we're all in this together. I'm here to help you. Feel free to ask as many questions as you want. And yeah, let's start diving into some of the labs here or some of the big
Can I ask
ideas
one
for
quick question?
this week. Of course.
The I assume that the little mini quizzes through the middle of the content, those are not graded, right? But the one at the very end of the module, that one is graded every week, right? So as long as
No.
I figure out which ones I got wrong on the mini quiz, it doesn't tell you what the right answer is. That's the downfall. But I got to go
Yeah.
back and figure out which ones I got wrong, and then that should help me on the quiz, right? Basically.
Yeah.
Yeah.
Exactly. Yep, you're exactly right. I also like honestly, I don't really care if you kind of chime into any of the like module 1 discussion forums and be like, what's the right answer to this question? And we can help you out. So as well as a class, right? I want you all to be engaged kind of with each other on the forums as well as kind of in Zoom whenever we have our live sessions. But yeah, to answer the question, the only quiz that actually matters is the very last one at the end of the module. I'm also 90% sure that this has to be done, or at least mostly done, to unlock the next module, or it should be. Your goal should be to finish the module quiz before you start working on the next module. This quiz is graded, but as you'll also see by the grade book, it's only like 3% of your grade. Each week module is 3%, and then the final capstone project that we're going to do at the end is like the actual grade. It's like 70%. So the capstone's pretty cool. You're going to go off, find your own data set, build a model, and then kind of do like an analytical write-up on it, which will be fun. Do you have a follow-up there, Jen?
I'm good. Never mind.
Sweet. And then, yeah, I haven't taken the 110 quiz yet, but I would assume it's going to be very similar questions to what you'll see at the end of the media sets.
Actually, I will say one more thing.
Go for it.
If you're following on time on with the data that's being provided as far as the course wants you to progress, today's live session for me came exactly in order with what I finished, for example, over the weekend. That's a good pace, right? Like this is perfect.
Yep, exactly. That's spot on. So again, our live sessions should be at like again, you'll see that 1.8. It's assumed hopefully you've done 1.1 to 1.7. Correct. Again, it'll be flexible. You don't have to finish all this. I don't think there's any prerequisites before attending the live session. Just know that usually I'm going to be covering the labs that you kind of did or any of the hands-on work that you're supposed to be working on asynchronously. Sweet. Yeah, because I think after this, it's just a kind of some last level summaries and everything as well. All right, let me dive into some content here. We'll kind of ramble for about 30, 35 minutes and then kind of wrap up and kind of throw it back out. Again, week one, there's actually not that many expectations. I know if you click through some of the notebooks or look at some of the code, it's kind of insane and intense. Like, what are we doing here? Making decision trees and doing all this kind of crazy work to get data. There's no coding assumptions in week one. The big idea for week one is just to kind of get your head around thinking like a data scientist, thinking like a data analyst, thinking like a data-driven business executive, right? So kind of what is data science at a high level? How do we start actually putting data science into practice? Right. I like to say we don't just analyze a data set just for the sake of it, right? Like, oh, cool, I found this CSV on the ground and now I'm going to make a pretty bar chart, right? That's not the point of data science. The point of data science is to actually dive into business oriented data sets, take in specific questions or maybe find questions as you start interacting with the data, and then use your final outputs to tell a story, tell the truth, and kind of make decisions, right? That's kind of the end goal here. How do we make smarter decisions? In baseball, our key purpose of using data science was to help give us an understanding of uncertainty. And you'll hear this around other industries as well. Anytime you make a decision, like what kind of restaurant should I open, or which projects should I prioritize, or how much of my portfolio should I allocate to kind of this stock or this kind of ETF, right? That's always a decision made in the face of uncertainty. So what do I mean by that? You don't actually know how many people will go to this restaurant that you opened up. You don't actually know if this stock that you want to put your portfolio into is going to go up. However, with data science and with analytics, we can start putting confidence, and confidence intervals is something you'll hear about. We can start putting confidence intervals around these decisions. Given historical patterns of kind of this area, these demographics, we expect, and given similar restaurants that we saw opened up in the last 12 months, I would expect those similar trends to happen with my own restaurant that's opening up, right? Given similar stock historical performances, given current market conditions, I'm going to use all of this to synthesize a model to help me predict the likelihood that this stock will go up, right? Or predict, in baseball, is like predict the number of home runs that this baseball player is going to hit kind of next year, right? Predict how many goals this guy is going to score, right? So how do we better kind of understand kind of the decision-making process using analytics? So the only key thing to highlight here is going to be the crisp DM kind of methodology, or as you'll kind of see through a lot of these IBM kind of slides, just the overarching kind of business understanding, the data science and methodology. So the crisp DM, you're going to see this thrown out a lot. I'll drop some of these documentation links into Zoom chat, and I'll try and synthesize a few of these into our forum post too at the end of the session. But I also really want to highlight that thinking like a data scientist doesn't really mean being kind of restricted into any of these, I guess, processes or SOPs. Honestly, a lot of it is common sense, as I like to think about it, but it's still good to highlight some of these key kind of focuses here. So the CRISP DM has actually been around since the 90s. It's pretty good at a high level. you'll see that it actually has some limitations in kind of the modern era of data science, which we'll talk about a little bit later as well. But we'll kind of go over it as its key methodology. I'll also kind of really want to highlight a couple quick things here. You may have heard of a lot of different terms. Data science, data analytics, data engineering, what's some other ones? Data mining, machine learning, AI. Let me see if I can find this Venn diagram. Boop, boop, boop. Love it. So data science is really going to be a confluence of computer science, mathematics, and kind of domain expertise. So it's different than data analytics. Data analytics typically is just requiring some database, some basic high-level data munging. Essentially, data analytics has less of a focus on computer science. Again, that's going to be your programming. So data analytics would be something like open up Google Sheets, open up your Excel spreadsheet, create some graphs, right? Maybe query a database, bring some information back, and make some dashboards. You may also hear this like a BI analyst, a business intelligence analyst, etc. You may also then hear like AI engineer, ML engineer. Those focuses are exclusively on building models, right? I only want to build an AI model. I only want to build a machine learning model. I want to build a regression model. Again, we'll talk about models here in a second when we come back to CRISP. Data science is really the confluence of all of this, right? We're going to be using programming to help automate a lot of our data collection. We're going to be using programming to help create and train our models. We're going to be using tools like SQL, like Excel to be able to do basic analytics on top of that. And then, of course, we need that domain expertise. Really, the crutch of data science is going to be that storytelling. That's storytelling and truth telling. How do we explain our work, explain the decision process, explain the uncertainty to non-technical stakeholders, your executives, your managers, people that may not actually have a lot of that understanding. So data science is the whole shebang. It's going to be taking data from source, cleaning it up, making it pretty, making models on that, and then synthesizing all of it to tell a data story. Data analytics does a lot of that without code, and machine learning AI is only the modeling piece, which is where we try to use historical data to help us identify patterns that may translate to the future. All right, so back to CRISP, CRISP DM, the cross-industry standard processing for data mining. That may be on the quiz. I would probably say that's probably on the quiz, so to know what it stands for. But yeah, so this methodology basically says, let's start at the business, right? We never just do data science, data analytics in a vacuum. What is kind of the business problem that we're trying to solve here? So you see the example that we're going to be walking through in our labs. It's going to be analyzing recipes, right? Can we predict the type of cuisine from its ingredients? So maybe the business question we're trying to ask here is, given that I want to open up a, let's say, like East Asian restaurant, what are the ingredients I'm most likely going to need? And maybe we can even then use that to maybe proxy against expected costs of kind of the goods required to run this restaurant, etc. But we want to start with a business understanding. What is the high-level problem that we're trying to solve? Once you have the high-level questions or the business problem, then we actually go to the data. And again, this is still where a lot of people skip the steps, right? We just go straight to the data and then find questions to ask later. That's why you'll see when we did module 1.2 in that discussion forum, we didn't just find a data set and go, look at this cool data set on NFL attendance, or look at this cool data set on like floods or airline safety. How do you use that data set to start thinking about questions, right? So it's a little bit backwards in our point. In an enterprise setting, what happens is that you have a data warehouse. You have this ecosystem of many data sets that your business owns and operates. And typically we start with a business question and then go to the data warehouse to find the data sets that we think are going to be relevant to that question. In our Kaggle example, we kind of did it the other way around. We found a data set, then found some questions for it. At the end of the day, right, we want to have questions. We want to have hypotheses before we actually dive into the data. If you just start getting carried away making leaderboards and bar charts without actually having questions or hypotheses that you want answered, you're going to have a very unstructured analytics project, right? So understand the business requirements, understand the data sets that you have, and then use those data sets to start answering questions. You'll see that there's a lot of let me get my little red pen out. You'll see there's going to be a couple back and forth arrows between the business understanding and the data understanding. And this is part of that iteration, right? A lot of the analytics projects will have flexibility to them, right? So for example, maybe your business question that you have, we actually don't have data on it, right? We don't have data on, let's say, the demographics of this area where you want to open up a new restaurant. So we have to go back to the business, maybe try and find a different type of question to ask, maybe try and find kind of different data sets that will be needed to answer those questions. So this is an iterative process to go back and forth between your business questions and your data sets to find that confluence of what's actually needed to actually run the project forward. To me, this is the most important part. Data projects are most likely going to fail if you don't have a clear business understanding or a clear understanding of the data sets needed to answer those questions. For example, at my time with Databricks, with my time with the Rangers, we see this a lot with AI, right? Your executive says, "Hey, I want to use AI to make my business better," but that's such a vague kind of requirement. And then people go off and they spin up some ChatGPT wrapper chatbot right on top of their business documents. And then nobody uses it, or the chatbot's not very good. And it's like, okay, we just wasted all this time and money kind of putting together this analytical data product that nobody uses. And maybe it's because we misunderstood the business requirements, the business understanding of what actually we want to do to make value out of AI, right? Or to make value out of these unstructured documents that we have in my corpus. So really, I'm harping on this a lot. I think it's just a couple slides in the media set, but the business understanding is the pivotal place to start and create a foundation for your analytical project. Then we get into the technical stuff. So we'll kind of start diving into those. On the technical side, I'm going to wrap up data preparation, modeling, evaluation, and deployment as like one whole section, the second section of the actual project. This is the work that you have to do as a data scientist. And I like how Chris kind of emphasizes these 4 separate boxes, because as you'll find, many data science projects has this repeatable pattern to it. Once you have your questions, once you have your data, now we have to clean and prepare the data. So examples of cleaning the data can be things like renaming your columns, fixing your data types, right? We see this all the time in Excel. How do I make this a number? How do I make this a date? You type in 1-5 and it thinks it's a date and not a fraction. So cleaning up all your data types, cleaning up your column names. There's also some more esoteric examples of data cleaning that you'll see over the next few weeks. Things like fixing null values. If your data set is missing values in a row or a column, what do we do about that? Or anomalies. You may start thinking about, some of y'all talking about anomalies in the forum, which was really good. So things like, is this, or let's say I have a data set of all the like East Asian restaurants and their revenue in my area over the last 5 years. Let's say one of these restaurants has a huge amount of revenue for some reason. They made $5 million when all these other restaurants only made like 10,000. That's an anomaly, right? So now we have to say, is this a real data point or is it actually a malfunction? An example of a malfunction would be, again, coming from my baseball background. Sometimes we would have a camera tracking the like pitches and stuff, and sometimes those broke. So a camera might say, oh my gosh, this baseball was traveling at 200 miles an hour or like 350 kilometers an hour. That's obviously not going to be true. You can't actually throw a baseball that fast. So we need to make sure that we remove that from the analysis. The idea is that if we start taking things like averages, your mean, median, mode, and range, as we start kind of making some of these summary statistics, we don't have anomalies biasing our data sets. Once we've cleaned and prepared our data, then comes the fun stuff. which is actually using this data to try and understand the world around us. So we call this modeling. With modeling, the traditional definition is going to be things around your machine learning algorithms. This is be things like a regression model, y equals mx plus b. We're going to come back and do all those in a few more weeks as well. How do we kind of train a model, whether it's a linear model, a decision tree, a random forest? How do we train a model on our data to help us predict and understand the future? There's other ways to define modeling, though, and sometimes it can be just as straightforward as creating leaderboards, right? I want to create interactive data models, these leaderboards that people can then just interact with and filter. So again, coming back to I'll come up with some other kind of non-sporty analogies next time, but baseball is a super nerdy sport. There's a lot of hardcore folks out there that just love looking at the numbers. So I like just coming to kind of some of these pages here. So this is just like a leaderboard, right, of how good you are at baseball. You don't even have to know that much about baseball and to see that, all right, these two guys are at the top of the list, Aaron Judge, Shohei Ohtani. They may actually be good at baseball, right? This is an example of data modeling, right? So think about the data products that you need to answer your questions. If my business question is, I want to surface information, I want to democratize access to data, I want to democratize who can make decisions off of this data, then my data model is going to be things like interactive leaderboards, interactive visualizations, your BI tools. To me, that still counts as part of this modeling. If your business question is, I want to predict or I want to have confidence in understanding who is going to hit the most home runs next year, then my modeling will be more along those lines of linear regression and the decision trees, the random forests, using machine learning to help us use patterns to predict the future. So again, long story short, the data modeling phase comes from the business understanding, the business questions, and what kind of product you're trying to deliver, and then actually going down that line of training the models, building those dashboards, etc. Finally, we get to evaluation and deployment. Again, the only thing I want to call out here is how the evaluation arrow is also gone back to the business understanding. Does whatever you created as a data product, whether it's a machine learning model, whether it's a dashboard, whether it's a leaderboard, whatever you created in the modeling phase, does it actually answer your question? And if it doesn't, then you should probably kind of go back and figure out what you did wrong or kind of where to go from there. And sometimes the actual answer to the business question is like no, right? Or I don't know, or there's too much uncertainty. But there should be some relation between whatever you created and the whole purpose of this data science project in the first place, right? Again, we don't just create a model just because we like creating models. We don't create leaderboards because we love leaderboards so much. We try and create a lot of these products to influence or impact business decisions down the line. And then finally, once we're confirmed that yes, whatever we created is matters and works and kind of meets the needs of our expected users, then we move into the deployment phase, which is deploy the model into production, deploy the dashboard to your end users, deploy your generative AI chatbot to your end users, deploy your leaderboards to your users, etc. So how do we actually then justify what we built and make sure that whatever we built is actually driving those business use cases forward? There's a couple like other nuances to this kind of whole data like science project. One that you'll hear a lot more now is the addition of feedback. So before I get to that, actually, CRISP DM has been around since the 90s. Very kind of high level idea of running a data science project. Figure out the business question, get the data, clean the data, create your data product, evaluate that data product, and deploy it. In kind of the modern era of data science, which we kind of typically go from like 2015 to 2025, 2012 to 2025, this is with the advent of something known as big data, as well as cloud computing. So again, I highly recommend hitting optional module kind of A around like big data and kind of analytics and a lot of kind of these modern kind of things. Just to kind of give you an exposure to the modern place of data analytics. But one of the biggest changes, IBM updated this methodology to now include the John Rollins, let me find it, crisp DM updates. Yeah, foundational methodology of data science. That's what it's called. Let's see if I can drop one of these in. I'll upload this to one of the chats too. This is one of the white papers, but this is the one you're going to see a lot more throughout the course in week 1. It's going to look, again, this is also like an advanced version of this crisp DM data science project. There's only a couple things that are different here. He kind of broke out some of the data engineering a little bit more, mostly because in the era of big data, it's exactly what it sounds like. There is so much data everywhere. It's how do we actually pinpoint down what we need? Right. So for example, if you throw a baseball, you watch a race car, you kick a soccer ball, you actually can track all of these motions at frames per second if you think about all these high quality videos. Or think about like Amazon. How often are people leaving Amazon reviews, right? Very often. How many reviews are being generated a second? Hundreds of thousands, millions of reviews in a day. How do we synthesize and integrate kind of that data at scale? So there's some additional requirements around understanding what data you actually need. But the most important one to me on here is the addition of feedback. So after you deploy the model and deploy the data product, remember, we are creating things for our customers, for our consumers, people that use your model, people that use your chat AI bot, people that use your dashboards. They are your customers. And what we create should be curated kind of for those customers, right? So the idea of adding feedback in here is, let's take user feedback as the users finding and getting use out of these data products, these data models. Or actually, if it's generative AI, let's actually keep track of whatever the model says or does, right, and get feedback off of that. You actually see this with ChatGPT. Sometimes it asks for a thumbs up or thumbs down, right, whenever you kind of ask it a question. That is OpenAI getting feedback from you to try and make its products better, right? So you're going to see a lot more of this requirements of actually gathering feedback from the deployment of your data models. But I would definitely make sure you have both of these kind of ideas in the back of your mind. The first being crisp DM, which is kind of the main one of our overarching kind of data science foundation. And then the updated version for the kind of advent of big data, which is going to be the Rollins foundation method for data science. Cool. Again, I've not shown any code. We've not talked about code. That's a week 2 problem. So you got 2 more days before you can start panicking about figuring out how to write code. So now we're going to kind of take this idea and translate it to the labs that you saw. So quick note on the labs. As I mentioned earlier, the labs open up a Jupyter Lab environment. This is a cloud-hosted workspace for you. You should be able to run all the cells and everything kind of in this environment. To get it to work for me, I had to refresh it a few times and kind of update and clear my kernels and things as well. But it should end up working. If you don't want to interact with the notebooks through Jupyter Lab, which for me, I actually prefer running things locally on my computer for the class, just so I have more control over it. In optional module B, it'll go over things about how do we actually set up a Jupyter Lab and some of these other kind of ideas of what actually are we doing while programming, right? How do I get started with Jupyter? How do we start using with Datasets and Jupyter notebooks and things like that? I definitely recommend looking at anything related to Jupyter on some of these examples, as that'll kind of help you with here. So if you have questions about actually running and setting some of this up on your own, definitely reach out to me on the forums, and Karen and I can help set you up. But you'll see, for example, like I'm going to be running my Jupyter notebooks on my computer, and I'm going to be running it out of Anaconda. So again, I think there's a video of that too somewhere in the optional module B. So long story short, you have 2 ways of running the labs. If you want to stay in your browser, when you get to a lab in the module, you can open it up inside of this Jupyter Lab, Jupyter Lite environment, which is a cloud-hosted server where you will just be running the code. Note that in a environment like this, technically, you don't own this code. You don't have this code to reference, right? You haven't downloaded it or anything. So a couple life hacks. In the URL, it'll actually tell you the notebook URL at the end here. If you just copy this and then like paste it in a new tab, it'll download it for you, which is kind of fun. I think there may be other direct download links from the course as well. So to run the notebooks, you can either run them in this browser, that's the easiest way, or you can set up and run Python on your own computer locally. And I think we'll walk through how to do that next week. So again, for right now, you don't have to know anything about coding. You don't have to have set up your Python environment or anything. We'll get into this more a week from today. All right, so let's actually take a quick look at these 3 labs that you had in your section. So again, I'm just switching to my local version. Again, we'll kind of dive more into this code next week. So big idea here, we need to go from requirements to collection. How do we move from business understanding and business questions to actually gathering data? What is an example of this looking like? So in our example here, our business requirements is I want to understand what ingredients are most impactful or common to different cuisines, right? What actually goes into making a dish a Thai dish versus an Indian dish versus an American dish? So that's kind of my overarching question. I want to understand the relationships between ingredients and cuisines, right? So now that we understand kind of our data or our business requirements, let's talk about how to actually get data. You'll hear this a lot, the 3 different types of data. So data can either be structured, unstructured, or semi-structured. We'll talk a lot about this over the next month. For our cases, the easiest data to interact with is structured data. Structured data just means rows and columns, and your data kind of looks like a spreadsheet. So in our example here, we've already found an open source data set. So an open source data set is exactly what you found on Kaggle, right? It's a data set that someone else has already created and curated and provided to the general public for kind of no fees or anything. So in this case, we actually have a public data set where our friend here went out and scraped tens of thousands of recipes from different websites and curated that into a CSV. Again, I think there's a couple questions on how do we actually download or get this data. If you just run the notebook, it should automatically kind of fetch it into your data set, or you'll see this recipes.csv kind of show up here. And again, little life hack for you. If you actually just take any of these URLs that end in a like a file format like .csv, you just paste that into a new tab. This will actually also download the data set for you kind of locally. So this is actually a pretty big data set, around 65 megabytes. So in my example here, all I'm doing is I'm fetching this CSV that we just downloaded, and then I'm reading it into a data frame. Again, you don't have to know how to code. You don't have to know any of this. Big idea is get your data set, figure out where it is, and now we have to turn it into an object that we can interact with code. Remember, data science is going to have a lot of computer science involved in it. It's not just regular analytics. We're just making dashboards and queries. We're going to be actually generating and interacting with data with code. So here's kind of what we've done. We've taken this CSV and we've read it in as code into an object that we can interact with coding logic. So in this case, we're using something called pandas. Pandas is a library within the Python language that makes it easy to interact with data. You don't have to know much about it right now. You're going to be using pandas a lot in weeks 3 and 4. And like I mentioned, highly recommend doing some of the Kaggle learns. They even have one specifically on the pandas library. So if we go back to our code here, we can see that this is what my CSV or my Excel table looks like. We have a whole bunch of columns with a whole bunch of ingredients. We have our cuisine column, and I can see that we have 57,000 rows and 384 columns, which is kind of a lot of data. The other thing to quickly note, though, is the quality. Actually, I'll come to this in the next step when we go to preparation. So there we go. We've gone through our requirements and collection. We've determined our business requirements. We want to look at the relationship between ingredients and cuisine. We found an open source data set and we've downloaded it and made sure that we can interact with it with code. The next section is going to be on the data cleaning. And this is kind of a wild, long section. So we won't go too deep into all of these. And again, you don't need to go deep in all of these on your own time either. The big idea for week 1, thinking like a data scientist. That's all you got to take away, right? Nothing about coding, nothing about actually creating anything yet. Just start to think like an analyst, like a data scientist. So in this exercise in lab number 2 here, moving from understanding to preparation, the goal is to take our data set that we downloaded in the previous exercise and clean it up to make it ready for modeling, right? To actually help us answer questions. So just looking at our data set, there should be a few things that jump out to you, right? I always tell people, my students, like, think critically, look at where your data is bad, right? That's kind of the idea. Where does your data suck? So how is your data bad, right? All data has parts of it that is terrible. So it's our goal as data scientists to understand that and then try and mitigate that as much as possible. So a couple things immediately jump out to me. The fact that all of these data types are strings or text, right? If I actually make a new cell here, ooh, look at me live coding. Oh God. Recipes.info. That's not gonna show because I need to be boop, boop, boop. Hold on. Almond, Angelica, Anise. What are we missing? Brackets. Boom. Well, I already cleaned it down there. Oh man. Let me run this again. What I want to demonstrate is looking at the data types of those columns. We're going to end up seeing that they are text. And one thing you should know about modeling and creating dashboards is dealing with text or strings is really difficult, right? It's really hard to when we make a machine learning model, we're just looking for numeric patterns, right? So trying to find patterns in text is a lot more difficult than finding patterns in numbers. So seeing all these no's, yeses and no's, to me, this is a red flag that we should probably fix and update our data types. There's a couple other examples here as well in terms of data cleaning that needs to happen. For example, we see that our data is biased. This is also a common pitfall in data science, right? If your data is biased towards one specific area or another, then obviously your results are going to also reflect that internal bias. You'll see things in there's a lot of I'm really passionate about this because this is really to me a frustration of data science. But for example, if you were training a model to predict crime, right? Your data set is going to be biased to kind of those areas where maybe there was different like demographics that don't actually kind of reflect kind of that crime. So you're just perpetuating biases and stereotypes. So same kind of idea here. We see that 40,000 of our recipes are classified as American. That is going to really bias any model that we have in trying to find patterns. It's going to see that a majority of ingredients all kind of relate back to being American, which I guess kind of makes sense. Again, living in America, we have a big hodgepodge of different ethnicities and kind of food and different ways that these recipes come together. All right, so let's go through some of the things that we're fixing here. Notice that some of my actual values for cuisine also aren't very standardized. Sometimes they're lowercase, sometimes they got dashes. All of this is gross and disgusting, and we're gonna start interacting with gross data a lot over the next 2 months as well. So let's fix our problems. Again, at a high level, let's clean up our data. We're gonna rename the country column to be cuisine. We're going to standardize all of my different cuisines here. For example, UK and Ireland, we're making UK and Irish. Irish, we're also categorizing in that group. Same thing with Spain and Portugal, we're classifying that as one type of cuisine. So a lot of cleaning up our categories. And then finally, we can clean up our yeses and nos and make them numbers. We can make them integers. And now I'm gonna do that risky live coding again. Let me actually grab that first cell from up here. Where are you? If I look at these same columns now after I converted the yes, nos to zeros and ones, we should be able to see that they are now integers. And that's exactly what we see. Almond, Angelica, and Anise are now integers, which allows us to find better kind of numeric patterns in the data sets. And in fact, what we've done here now is just found rows where these recipes contain rice and soy sauce and wasabi and seaweed. And we can see that these seem to correlate, ooh, vocab word, to different cuisines like Japanese, Asian, and East Asian, which I guess makes sense. I'm going to run through these questions. Based on the results, can we classify all recipes that are contain rice, soy, wasabi, and seaweed as Japanese? The answer there is no, because we have other cuisines such as Asian and East Asian that also utilizes those ingredients. Boop, boop, boop. Cool. What are the three most popular ingredients in our data set? Egg, wheat, and butter. Also, always trust your gut when you start looking at data as well. Does it make sense in our recipes that the most common ingredients are egg, wheat, and butter? Thumbs up, thumbs down. Does it make sense? Or are these kind of weird ingredients to be at the top? We would expect this, right? I'll get some class participation next time. I think these are expected, right? Egg, wheat, butter, onion, garlic. These are all used in almost every recipe I make and every recipe I imagine some of y'all make as well. So it makes sense to me that these are the most popular ingredients in our data set. Finally, the last thing that we started doing is start organizing and synthesizing our data. We're grouping by our cuisine, and we can look at our numeric averages, right? What is the most common ingredient per cuisine? And we can see some really interesting things here. Almonds are used in 15% of African recipes. And if we go across to butter, where are you? This one cracked me up. 41% of American recipes utilize butter. USA. Anyway, all that fun stuff. Same thing for Canadian. We also had some high butter preferences there. So last thing we did some more data understanding, right? Again, I like to think of this as a sanity check. Does it make sense what this data is telling us? And again, I think it does. Asian recipes contain a lot of soy sauce, ginger, garlic, and rice. That validates my experience kind of with that as well. Eastern European, wheat, egg, butter, onion. Indian, cumin, turmeric, onion, coriander. Italian, olive oil, garlic, tomato, onion. So I think this makes sense, right? My data now I feel is maybe a little bit more trustworthy. I have trust in my data because of this cleaning, this preparation, and this understanding of the stories that it can tell me. The last notebook, which you don't have that much time to go over, by design, I don't want to spend a lot of time on this notebook because it'll blow your mind, and we don't have time to blow all your minds yet. Remember, a lot of this modeling we're going to start doing in weeks 8 and 9. But the last part that I wanted to mention on kind of our labs here is once you've cleaned and prepared your data, it's time to use your data, create your data product, right? What's the point of this data? We want to build models, we want to build dashboards, we want to build leaderboards, we want to create a product. So what this last notebook does in your lab is that it creates a product. It creates a predictive model to predict, given your ingredients, the probability that it's going to be a specific type of cuisine. So that is the tooling here. So maybe its use cases, you open up the fridge, you input tomatoes, garlic, olive oil, and it'll spit back that you're making Italian food tonight. I don't know, but maybe that's a potential use case for this product. So again, the first half, the notebook is exactly the same. Read in the data, do all of our data cleaning, and now we can train models. The model that they train here is something known as a decision tree, which again, we can talk about in office hours if you really want to, but it is a model that takes historical patterns in our data set to try and find patterns to predict the future. So I really love decision trees as a way to visualize patterns. And that's actually what they did in this first cell here. So for example, what we're trying to learn here, if a dish has no cumin, less than 50% of the dishes are cumin. If that's true, we go down the left side of the tree. If our recipe has no sesame seeds, right, less than 50% sesame seeds, we go down the left of the tree. And then depending on how much starch it has, if it has low starch, it's Korean. If it has high starch, it's Chinese. Pretty cool. And we can see the same thing on the right. Let's say it does not, it has a lot of cumin. We are greater than 0.5. We then can check to see if it has fish. If it does have fish, then it's likely going to be Thai food. If it does not contain fish, then it's likely to be Indian food. So we're starting to see these patterns coming out that these models are able to find, which is pretty cool. And then you can kind of see the same thing here, right? If the recipe contains cumin, but no fish and no soy sauce, it's probably, this is a probabilistic model, it's probably Indian food. So again, once you've trained the model, the idea is to evaluate it to make sure that it actually is working as expected. So if we scroll on down here, that's what we do at the end. We get data that we held out of our model, data that the model has not seen. We then evaluate how well our model predicted on that unseen data. And we end up with a beautiful little confusion matrix like this. You don't need to know what this is. We'll cover this in weeks 8 as well. But the idea here is, given that you created a product, right, you're not done. We have to evaluate to make sure that our product is actually viable. And in our case, when we evaluate our product, in this case, our machine learning model, we see that it's okay. It's not great. For example, only 50% of Chinese food is actually predicted to be Chinese food. 36% of the time, it predicts it to be Korean, right? So actually, the best cuisine that our model is able to predict is Korean. 86% of the time, it accurately predicts Korean food. And Indian, 76% of the time, it accurately predicts Indian food. So again, that kind of again makes sense. They're very distinctive ingredient palettes in kind of both of those cuisines. Well, maybe Thai gets confused with Korean and Indian, and Chinese gets confused with Korean in my model. So your last couple questions. How accurate are they with Japanese recipes? And with Japanese, we're actually not that great. Only 40% of Japanese recipes are predicted correctly. It gets confused. The model gets confused with Korean recipes and Korean cuisine. And so how many Korean recipes are misclassified as Japanese? 37% of all of our Japanese recipes are misclassified as Korean. I guess the other way around. How many Korean recipes are misclassified as Japanese? 6.67% of Korean recipes were predicted to be Japanese. And then what is the most accurate cuisine? And that's going to be Korean food here. So in big idea, you don't need to know if I'm just speaking gibberish about confusion matrices and predictions and things. We'll get to that in a couple months. Big idea though is once you create a data product, don't just say it's good and move on. Prove that it's good. Why is your leaderboard good? Why is your dashboard good? Why is your model good? Do you have trust and confidence in your data product that you created to let other customers in the wild use it? Again, this comes back to that idea of connecting evaluation back to the business understanding, justifying your model creation. And then there's no lab for deployment, but that's going to be, like I said, releasing your product into the wild, letting other people utilize your machine learning model, letting other consumers use your dashboards or your leaderboards, etc. And that should be all the labs here. Again, for week 1, if you are having trouble running the code and stuff, it doesn't really matter in week 1. We will actually be running kind of the code in week 2. So be sure to reach out to me and Karen on the dashboards if you have questions around that. Otherwise, a couple minutes over, but hopefully this was a good explanation of the course and kind of the first kind of few labs here for week 1. So I'll stop rambling and I'll turn it over. Rod, Michelle, if you all have questions for me, happy to kind of take them now or you know I can talk until bottom of the hour if I have to. Coming attractions. Yeah, good stuff. Yeah, so open it up to y'all online if you have any thoughts about what I just went over. Karen, if you have anything you want to add.
But yeah, I was just that's what I just made that comment in the chat because it says like all this. Don't worry about any of the coding and stuff in this. Just see it as like a preview of what you'll be thinking about later. So it's all fun stuff. Very interesting thing what I find with decision trees is you can actually then use them to find out more about the data, what's really important.
Yeah.
You can actually get the importance of each feature that it uses, and you can also look at that tree. And so that's a nice way of also analyzing the data, kind of like you let the model digest it, and then you learn from what it digests.
Absolutely. Those actually, I think I'm gonna, oh, Michelle, yeah, you're online. I'm gonna steal your data because I thought this was a really good data set. So kind of an example, right? Again, like for the lab modules, it's all about this like food and recipes and ingredients and everything. But kind of in the real world, it's gonna be something like this. Let's say you work in agriculture, right? And you want to kind of start making kind of models on this. I don't know how much you actually poked around, but if you actually click on the code tab here, you'll see other people. Again, Kaggle is kind of this open community where people are like analyzing and kind of making like decisions and trying to do data science on these data sets. So this is a really good one, the analyzing crop productivity. And again, you can kind of see that they kind of really take that business understanding. What am I trying to do here? I want to try to increase productivity in my agricultural lands. I'm going to understand my data. Here's some high level examples describing the data and its data types, and then doing some data analysis. Same type of idea, right? Looking at the unique categories, looking at the different types here. Is there anything that we can combine based off the weather conditions? How do we find outliers or anomalies in my data? And we actually, I don't think, yeah, they found some outliers in yields ton per hectare, which again, maybe makes sense, right? Maybe there was some areas that actually had a ton of crops, but maybe that biases our data set a little bit. So I'm starting to think like an analyst, right? Where does my data have bias? Where is my data wrong? Where does my data have limitations? And how can we start fixing that? And then we can actually make beautiful charts like this, which we'll start doing in the next couple of weeks. So this is actually known as a bell curve. I would actually look at this and say there's no actual outliers here unless they already removed them. I think we have a beautiful little bell curve without any crazy outliers. Just as a fun fact, if you do have outliers, your bell curve would look something like this. It'd have like a really long tail to the right or a really long tail to the left. So an example of when you would see outliers in a distribution, my kind of thought exercise for this is like set company salaries. So if you look at all the salaries that gets paid out in your organization, most of y'all will probably be making the same kind of money. Let's just say between like $50 and $150,000, but then your executives will be making millions. So in that case, your distribution of salaries would look something like this, right? Where this would be like 100,000. And then over here you have your like 1 million, 10 million kind of dollar salaries or wherever you are salaries. So that's going to be a skewed or anomalous kind of distribution. So that's why I like this one. This is a nice, beautiful little bell curve, awesome box plots and other types of plots to kind of tell our story, right? So that's kind of where we're going, right? We're going to start doing a lot of this over the first month. I call this exploratory data analysis, EDA. How do we take our data, clean it up, explore it, create visualizations, create reports? And then in the second month, we're going to do a lot of machine learning. How do we start building models on this data to actually predict the future, or at least identify patterns in the data at that current point in time? And then the last kind of week or two of the class is a capstone project where you go off in the world, find your own data set, do an exploratory data analysis on it, build a couple machine learning models off of it, write it all up as kind of a final story, and then call it a certificate. So that's kind of the plan here for the next couple of weeks or couple of months. Cool. Yeah, great data set, Michelle. Double thumbs up. Let's see, what else we got? Anything in chats or Michelle, Rod?
No questions, really. It was a good explanation.
Yeah, no, it's good stuff. I'm gonna try and I'm pretty sure, let's see how much I can sneak ahead to next week. Uh, I'm not sure how much of this you'll be like installing kind of on your own for Python. But yeah, we'll be running a lot of code next week. So definitely feel free to reach out if you have difficulties with the installations. And then I highly, highly, highly recommend the Kaggle Learns for Python and programming. These will kind of pair up nicely with next week as well to see you some extra experience. Let's see. I feel like I'm missing something. I don't know. I don't even know what else. Don't get bogged down by the code in week one. That's all I'll tell you. It's a lot, and we'll kind of build up to it as we go. But yeah, just look for as you start looking at these data sets and things, start looking at how other people are analyzing them. I think that was like that NFL data set too, or someone put in another clicking all over the place. I'm just looking at my feet around kind of the online campus as well. But yeah, that was like a couple other data sets in here. But yeah, once you feel that you're accurately like thinking like a data scientist, then you're ready to actually get deep into the code. But yeah, so this is another like data set, right? And if I click into the code, we can see how like other people have built models. So this one's actually building a model on it. The model is called Cat Boost and all kind of this jazz. Let's see. Yeah, again, it all starts with exploratory data analysis, right? Looking at the distributions, looking at the shape of your data, looking for outliers, looking for missing values, cleaning everything up, transforming all your work, and then finally building the model. There's a lot of good like memes and stuff out there. It's like an 80% of a data scientist's time is actually data cleaning. Just like making sure that your data looks right before you're actually going to do all the fun stuff like making models and making dashboards and things. A couple other questions that were thrown my way that I was aware of. The idea of modeling versus like generative AI has come up in the past in other kind of week ones like this. So this comes back to like what actually is kind of the modeling or your data product. In the era of big data and generative AI, the idea of a data product has transcended just a like dashboard or a report or a kind of machine learning model. A lot of kind of what we just talked about with like even just predicting cuisines, that is very like 1970 to like 2010 style of analytics and data science. Take your data set, build your model, call it a day, right? And a lot of the data products, I call them one-off products, right? The goal of this was to create a report that I then submit as a white paper and call it a day, right? No one's going to do anything with it again. That's obviously evolved now to things like these machine learning models that are reused. For example, I talked about how maybe this cuisine model could be used as an app, right? You don't know what cuisine you're going to make tonight, so you input your ingredients, tomatoes, cheese, olive oil, and it spits out that you're making Italian food. So now you're having a model that's being reusable. And now kind of in generative AI, data products have transcended to be all across, I call like the data ecosystem. So now you have videos, audios, images, right? You see ChatGPT and Sora making images. A lot of that are now data that you have to organize and manage. Documents, right? APIs, chat assistants, right? Your enterprise data. One of the most common things you'll see now is that people are uploading their private enterprise data into chatgpt.com, right? The open public like thing. And OpenAI just automatically gets your company's private data just like that, right? So how do we start in thinking about security and governance, right? That's all going to be part of your data product architecture now. And of course, things like chatbot, that's part of the data science like workflow, right? Using chatbots to both help you create the project, but then also maybe your product is in itself its own chatbot, right? Maybe that's how your customers will be interacting. You may have seen some of this now, which is like a text to SQL, or like a We'll see. I'll pull up the Tableau like ask data example. So this is the This is the idea that let's say that your stakeholder, they want to ask follow-up questions to your dashboards. They should be able to write out in natural language what they want to see and visualize, and then have that automatically be created and curated. But it's the data scientist's job to make sure that the data is ready to be able to handle this. And again, that feedback is the output of some of these natural language queries that people are interacting with. Are they actually answering those questions, right? So again, what's the actual quality and utility of these data products? I still work with some data scientists who've been in the field for like 30 years, and they still view like, hey, my goal is to make this one thing and then call it a day, right? And hopefully it works. But I think the vision of data science that we'll talk about this over the next 10 weeks as well. But I guess the responsibilities of a data scientist are now so broad as well that typically I find data scientists actually fall into specialized buckets now. So yeah, sure, maybe you're really good at the data cleaning processing phase. That becomes now a data engineer. Maybe you're really good at deploying your machine learning models. That's an ML engineer. Maybe you're really good at curating the data for AI synthesis, large language models. That's now an AI engineer, right? We even have this idea of things like ML ops, which we'll talk about in week 8 and week 9, which is the idea of maintaining the life cycle of a machine learning model or of an AI model, right? And now you can see that we have data, machine learning, development, and operations all around this. So as a data scientist, where do we kind of fit in, right? Are we like, to me, data scientists are unicorns, that they have an exposure to all aspects of the data ecosystem, but they typically will eventually find a spike in certain areas. So again, a lot of this class is going to be just going from a fire hose of the million different, especially newer aspects of the data ecosystem. But hopefully you kind of find an area of it that kind of sticks out to you to maybe double down on afterwards. And I just know how fast this space is moving. MLOps, this was like a huge thing in like 2018. It's like, oh my God, we got to have better governance, organization, CI/CD governance around all of our models. And then, yeah, with the advent of LLMs, that's now called like LLM ops. This came out like 2022. But just like, how do you like prompt? How do you kind of facilitate the development of production workflow for large language models? I'm actually going to see that a lot of this relates back to Crisp DM when he's take it back to a 10,000 foot view, which I think is really the impact of week 1, right? Think like a data scientist, think like a data analyst, because these same SOPs, these processes can be applied to almost like any product within your data ecosystem. So for example, looking at this is for LLMs, right? Or maybe look at this one. Get your data, experiment, and kind of figure out what product you're going to make. Evaluate it. Does it actually answer kind of the questions? Deploy the model, right? Monitor and get feedback, right? All that has a direct correlation with kind of the CRISP and the Rollins kind of methodologies that we've just discussed. So again, things to take away. Make sure that you don't always imagine modeling as a strict like linear regression or random forest. The actual model, or I call them data products. The data product that you create as a data scientist can be a regression model or a random forest model, but it can also now be dashboards. It can be knowledge assistants for large language models. It can actually be a fine-tuned large language model, right? It can be a web application or a like data, we call them data applications. You'll see this as like data apps now. Like, what are data apps and everything? What are data apps? Is it going to be like micro software applications that like creates and visualizes kind of data for you? Right, this is a relatively new thing, just as it's been easier and easier for people to use vibe coding, right? So using large language models to create applications. It's typically easier to meet your customers where they're at. So we didn't really talk about this in the deployment phase, but let's say that your creation is a dashboard. If your user is not going to log in and actually go to Power BI or Tableau to create this dashboard, you have to somehow put it on their phone, right? And maybe we can do that via apps or websites or microsites and things like that. So now this is now its own model, right? Coming back here, the data product that we're creating is now going to be a micro data app. I was like, golly, how are we supposed to manage that? And how do we also organize and govern these applications with my models, with my data sets, with my leaderboards? Right. I like to think that this website that I've shown today with showing these leaderboards, this is technically a data application. It's a software web application whose sole purpose is to curate and communicate data insights. And sometimes it's a data scientist that creates this. And honestly, in most cases that I see in teams, it's a data scientist working with a software engineer because the software engineer doesn't know anything about the data, but the data scientist doesn't really know how to create a good looking website. So how do we kind of use those together? But like I said, that's been changing a lot with vibe coding. Data scientists now have the skills and the co-pilots to create software applications to help them explain and serve data to a wider customer base. All right, I got 3:20 Eastern time. I'll just wind this back down, and then if we want to leave early, we can. So big ideas to take away from the class. Let's start with the actual kind of structure of the course, right? You get what you put into it. You don't have to pay attention to every second of every video and memorize every bit of text or everything that someone mentions. The point of this 10-week certification is to know what you don't know, right? Be exposed to so many different kind of aspects of the modern data ecosystem that you at least like, hey, I've heard that. Booth talked about large language models once, or LLM ops, or data apps. So just be aware of things going on in this industry and in this ecosystem, right? So that's a big idea of this. With that being said, you do need to pay attention to specific high-level ideas that we'll try and communicate during these live sessions as well as in the forums, right? So the purpose of week one, the big idea, think like a data scientist. What does a data science project look like? What does it mean to think analytically? What does it mean to try and tie data-driven decisions back to the business, right? What are visualizations? What is data? How can data be dirty? Like, just start thinking along some of those lines. Again, in week two, it's going to be much, the focus is intro to coding. That's all. It's going to just be like, do you know a little bit about coding logic and how to code now? So that's going to become the big idea for week two. Again, the structure, how this goes, you're going to have a whole bunch of async media sets to do. It's recommended to get all of them done before the live session, or at least the ones before the live session done. Again, you can work on it on your own time, invest as much time as you want into them. Then on Mondays, we'll do this live session where I'll basically go over the like labs and stuff a little bit more detailed. And then the next week opens on Wednesdays. Things that I need from you all, you have to at least post into the discussion forums at least just once. I think that's part of the module grade. And then the assessment quiz at the end of each module, that's also part of the grade. So we need class participation in the forums as well as the final assessment quiz at the end of each week. This live session is optional, but I love hanging out with y'all. And if someone's online, I'm more likely to talk and ramble and teach you things than if no one shows up to my live sessions. And just me and Karen just talking and shooting the shoot, I guess. But yeah, make sure to do all that. And then don't be too overwhelmed. I know it's very easy to get overwhelmed with the content and the materials here. So when you do start getting overwhelmed, just log off, literally just close the tab, go touch some grass, get outside, and then you can just come back and try and take a step back. That's always my like appreciation of this. What is the actual point of this week? What's the actual point of this media set, right? So again, for week one, what are the different aspects of this data paradigm, right? What does it mean to understand your data? What does it mean to clean your data, create a data product, and then deploy it into production, right? That was kind of the purpose of these three labs. But yeah, and then just communicate. Like I said, I log into this class usually twice a day, probably more. I have it permanently open whenever I'm doing anything on my laptop. So if you have any questions, I don't think you can direct message me or anything, but like I said, try and just post. There's no such thing as a silly question. So post as much as you want, ask whatever questions you want, and I'm gonna try and even have some like general miscellaneous forums for us to play around in. I may just do that. I may open a miscellaneous forum that I can just like post random
Good
news articles
good
and
idea. Good idea.
memes and stuff. There's a lot of good data science memes out there.
And it's always
Data
good to have
science memes.
some little bit of fun too in the process.
I know I miss having I guess we're recording, but we used to have like other like tools for chatting and stuff like Slacks and Discords and
Yeah,
things.
yeah, I did TA on a number of the boot camps when
Yeah.
they were still running, and yeah, we had the Slack and everything. And there was
Yeah,
always
they're not doing that.
there was always a random channel for just anything.
Yeah.
And then
Another reason
I
why
wish
for
more
this
people
one,
would come to this. I wish more people would come to this because I think when we have these sessions, we can remember the people you're dealing with and the forums are people.
yeah,
You
exactly.
see them and you hear them and you know.
Yeah, I'm not just a random person on the forum. I'm a real person trying to help you out. Yeah, and I was gonna say the reason I got told was just because they wanted to for like for with this like official certification, they just want to make sure that everything is tied to like audits and best practices, and we
Oh
got all
yeah.
these forums and things. So
Yeah,
we
I
don't just want
understand.
Michelle typing whatever she wants into Discord and slacking it out to the class, and it's like, what are you saying? But anyway, I'm gonna do that anyway. I'm gonna be dropping memes into some forums. I love this one. Coding, like, yeah, coding's the best. And then it turns out that like actually doing some of the mathematics or the algorithms and the most important is actually knowing your business and knowing the subject is actually more important. So that's actually a good one going into week 2. It can be very overwhelming to be coding and to interact with Python and code and coding logic if you've never done it before. But just remember that coding is a tool of data science. The real utility of being a data scientist is that storytelling, that communication, and that translating of business problems to numbers and then trying to use those numbers to be confident in making a decision, right? Coding is a tool to help that. So again, this isn't a coding bootcamp or a coding micro course. It's a data science micro course. So coding will be a part of it. But again, just reach out to me, Karen, if you feel overwhelmed with anything or
Yeah,
need
sure.
any
I would
further
say definitely,
explanations.
definitely as you start looking at the basics of Python, the syntax and so on, any questions? Unfortunately, I only get to tell you two guys, but maybe we should make it more general in the forum also that any questions at all about the syntax, anything of Python, feel, people can post a question on the discussion forum and tag us and we can soon respond to that, especially if it's tagged, we know, somebody's looking for us specifically.
This last meme, which is what is a data scientist? What my friends think I do, they do all the crazy stuff on the whiteboard. What my mom thinks I do, hacker man. What society thinks I do, control the world, look at all the data everywhere. What my boss thinks I do, make little basic spreadsheet visualizations. What I think I do, hardcore mathematics and modeling it. What I actually spend most of my time doing, getting data out of a database, cleaning and making it pretty. And that is 80% of your life as a data scientist, unfortunately. But
I did one like that for me for AI. It's just two parts. It's like as somebody doing AI, what people think of me, and it was like, Skynet.
yeah, right. Yeah,
And what I'm actually
exactly.
doing, and it's like a picture, from an actually app I did for practicing something. It's like it shows a piece of food and then it says hot dog, not hot dog.
Yeah, yeah, good stuff. All right, I got 3:28. I think we'll kind of wind this down. Let's stick online for another minute or two. I'll pause the recording here if anyone has off the record questions. Otherwise, it's been my pleasure. I'm excited to work with you all in this class. Michelle, Rod, thanks for sticking around to the end, and I will see you on the campus.